Greetings, mathematician. In this video, we are going to continue solving equations, and we're going to mix in working with the algebraic properties that we talked about previously. So first we're going to add in some new vocabulary here. When you solve an equation, each step along the way results in an equivalent equation. So equivalent equations are just equations that have the same solution. So an example here that's given to you, one equation is x plus 3 equals 5, and another equation is x equals 2. Those equations are equivalent because they have the same solution. As you're solving equations, you get from one step to the next by using inverse operations. Remember, those are things that undo each other. So if you need to undo addition, you use subtraction. If you need to undo multiplication, you use division. If you would need to undo squaring something, you would use a square root. And a solution is a number that when you plug it back into the original problem, it gives you a true statement. So x equals 2 is a solution to x plus 4 equals 6, because if you plug in the 2 for x, you'd get 2 plus 4 equals 6, which would give you 6 equals 6 once you simplify it, and that's a true statement. All right, so here is an equation for us to solve, and we've solved equations before, but what's new here is we want to identify which of the properties we're using. So what you want to do here is you want to be looking at the equation, you want to find the variable, so in this case the x is on the left-hand side of the equal sign, and then you want to figure out why is the x not by itself. So in this case, our x is not by itself because it's being multiplied by the negative 2/3. And then you need to figure out, how am I going to undo that? What operation is going to undo this? So the way we're going to undo multiplying by a fraction is that you multiply by the reciprocal. So we're going to multiply both sides by 3/2, negative 3/2 rather. So when you do negative 3/2 times negative 2/3, you get 1. So 1x. And then on the other side of the equation, when you do 10 times negative 3/2, you get negative 15. What's new here, though, is that we want to be able to say, what property did we use along the way here? So we chose to multiply both sides by negative 3/2 because it was the multiplicative inverse. That is what allowed us to get the x by itself in this case. So next up, I'm going to have you pause the video and try these problems next. So you're going to solve them, but more importantly, you're going to write the name of the property that you used to solve each problem. Then come back to the video to check your answers. All right, now that you've tried them, here's what you should have come up with. So for the first one, you would have gotten the b by itself by dividing both sides by negative 3, and that is the division property of equality. For the second one, you would have gotten the x by itself by multiplying both sides by 9. That is the multiplication property of equality. For number 3, you multiplied both sides by negative 8/7. That is the multiplicative inverse, and actually also the multiplicative property of equality. And the last one, you divided both sides by negative 1. That is the division property of equality. Went ahead and added that multiplicative property of equality there. Kind of two things going on for number 3. Next up, we're going to add some multi-step, or really more specifically probably two-step equations here. And what's going to happen here is that basically we're just going to add an extra step where first we have to simplify both sides of the equation. So you might have some like terms to combine, or you might have to use the distributive property before you can start isolating the variable. So before you can start dividing both sides by a number or multiplying both sides by a number or adding or subtracting both sides by a number, don't forget when you're trying to isolate that variable, you do have to do order of operations in reverse. So keep that in mind as well. So the extra step here, the new step, is that first you have to simplify both sides of the equation before you start isolating the variable. All right, so let's try a couple of these. So for this first problem, there's nothing for us to simplify. There's no like terms, no distribution on either side of the equation. So we're going to start right away with trying to isolate the variable. So on the same side as the x, we have some multiplication and we also have some addition. Remembering that we're going to do order of operations in reverse, the first thing that we will do is subtract 6 from both sides. So that's going to leave me with 1/3 x equals negative 14. Now, I kind of did two properties here. I subtracted 6 from both sides. That was the subtraction property of equality. And on the left-hand side, the positive 6 plus negative 6, that gave me 0 and left me with just the 1/3 x. That was my additive inverse. Next, I'm going to say, well, my x is still not by itself yet because it's being multiplied by the 1/3. I want to get rid of that by multiplying both sides by 3, or you could also think of it as 3 over 1 if that helps. What's going to help you to take the 1/3 and make it into a 1 to get a 1x. So it's going to give me x equals negative 42. And again, kind of two steps in one there. I multiplied both sides by the same value, so it's my multiplication property of equality. And then the 1/3 times 3, kind of canceling out. Again, it's a little sloppy, but turning into a 1x, that's my multiplicative inverse. All right, now moving on to my next example. This one I do have some like terms. I've got the 7x minus 3x that I can combine to get 4x minus 8 equals 24. For your reason for this, just write combine like terms. Then from here, we're going to add 8 to both sides to get 4x equals 32. And again, we're kind of doing two things in one there. We added the same number to both sides, so that's my addition property of equality. And on the left-hand side, we had the negative 8 plus 8, which equaled 0. And that is my additive inverse. And then it canceled out to give me just the 4x, because anything plus 0 is itself. That's my additive identity. Right, and then last thing I would do is divide both sides by 4 to get the x by itself, and that's going to leave me with x equals 8. A lot of things going on there, so I'm dividing both sides by the same number. That's division property of equality. On the left-hand side, the 4 divided by 4 equals 1. That is my, technically my multiplicative inverse, because really that's the same thing as doing 4 times 1/4 equaling 1. And then 1 times x just equaling x, that's my multiplicative identity. So all of that going on there. All right, and a few more examples here. In this one, we have some parentheses that we need to get rid of, which we're going to do with the distributive property. And then we also have some like terms to combine. We've got the 5x plus 3x to get 8x. Now to simplify that, subtracting the 12 from both sides using the subtraction property of equality. And when we typically are a little sloppy in saying that the 12 cancels out, really what's happening is the 12 minus 12 is 0, and then the 8x plus 0 is 8x. And those two steps are using the additive inverse. When we do negative 12 plus 12 is 0. And then the identity when we say that 8x plus 0 is 8x. And then last, we're dividing both sides by 8. And we can divide both sides by 8 by the division property of equality. Again, in the past, we've probably been a little sloppy here where we say that cancels out. Really what's happening is 8x divided by 8. 8 divided by 8 is 1. That is your multiplicative inverse, because really what we're doing is doing 8 times 1/8 to get 1. And then 1 times x is x, and that is your identity. So we're using the multiplicative inverse and then the multiplicative identity. Right, and one more example, again starting with our distributive property and then combining your like terms. And then next we're going to subtract the 6 from both sides. And again, there's basically 3 steps happening there. Subtracting 6 from both sides is your subtraction property of equality. Having the 6 minus 6 zeroing out, that is technically the same thing as adding -6, which is your additive inverse. And then x plus 0 just equaling x on the left-hand side, that is your additive identity. All right, so next up, we'll give you a couple of problems to try on your own, and then we'll compare answers. All right, so go ahead and pause the video, give these problems a try, and then come back to check your work. All right, and now that you've had a chance to try these, your work should look something like this. Again, you may have possibly done some of your steps in a different order, and that would be okay. So you should end up with the same answer, but your work might look just a bit different. So you should try to simplify first. So we distributed, we combined like terms, then we subtracted 2 from both sides. That's your subtraction property of equality. When you do the 2 plus -2 equaling 0, that's your additive inverse. When you're doing the 5x plus 0 giving you just the 5x, that's your additive identity. Then you're dividing both sides by 5, that's your division property of equality. When you're doing the 5 divided by 5 giving you a 1, that's really like 5 times 1/5, giving you a 1, that's your multiplicative inverse. And then 1 times x being x, that is your multiplicative identity. And then on your other side, distributing, combining like terms, then you are subtracting the 60 from both sides. That's your subtraction property of equality. Then you're doing the 60 plus the -60, and that giving you a 0. That's your additive inverse. When you're doing the -6x plus 0, giving you the -6x, that is your additive identity. Then you're dividing both sides by -6. That is your division property of equality. When you do -6 divided by -6, that gives you a 1. That's really technically the same thing as -6 times -1/6, so that's your multiplicative inverse. And when you do 1 times x and get just x, that is your multiplicative identity. So those are your reasons that go along with that. And then the check, remember you can always check your work by taking your answer and plugging it into the original problem and making sure that you get a true statement. And we'll go ahead and stop this video for now before we move on to some more equations in the next video. So bye for now.